Hey, GAP Math students, this is a video for Intro to Geometry, objectives 5 to 7. So you should take out your packet if you do not have that open yet. Let me get to the right packet here. So it should be on a page that looks like this. If you don't have it, hit pause, go grab that. So we have a little bit of notes to take before we start going through problems. So I'm going to start right here and kind of make a line going down here. We got a couple terms just to go over for definitions here, and then we'll just do some example problems. So first one is congruent. A lot of you might know what this means, or at least remember hearing about it. In short, a definition would be items that are exactly the same size and shape. Okay. They can be rotated or slid around or moved. That's okay as long as they're the exact same size. So example would be if we had, excuse my drawing, it doesn't look very good. If we had something like that, and might not look exactly, but that's why I'm drawing numbers in here. So all the sides are the same size. If it was a good drawing, I just had rotated it around, moved this right angle up here. Everything's the same. The other thing they would say is corresponding angles and sides are equal. So there's a 3, there's a 3, there's a 4 and a 4 on the side, 5 and 5 on the side. If I was more specific in these type of triangles, this would be about 53 degrees. This would be about 37 degrees. So same would be here. That's actually, I got that backwards. Not that that's a huge deal, but just I want to have it right. If I'm going to do it, that would be about 53 degrees. That would be about 37. So same here, the one across from the 3 would be about 37 degrees. And this one would be about 53 degrees. So all the parts would be exactly equal. So these two triangles, even though my drawing isn't great, would be congruent. Okay, similar. It's kind of how it sounds, but it's a little more exact than what it just sounds. Instead of just saying it looks similar, the general definition should be the same shape, but different size. So an example here would be if I took that triangle, whoa, bad, from above, and this might not be exactly. Okay, so they're not exactly the same, but they're similar And to be more exact, corresponding angles would be equal. So obviously the right angles are the same, but the angle, this angle would be equal to this one, and this angle would be equal to this one. But corresponding sides, excuse the sloppiness in the writing there, are not equal, but are proportional. So we in the last session we did some proportions, but that just means if it grows or shrinks, all the sides would grow or shrink by the same proportion, meaning 4 to 8 means times 2, 5 to 10 is times 2, 3 to 6 is times 2. Okay, we could, even do this again, and let's say that's a right triangle, and let's say that's 12, that's 9, and that's 15. Now these are all similar, even though it might be hard to look at this one to this one, because 8 to 12, what do I times by, or 10 to 15? But if you look from the original, 4 times 3 is 12, 5 times 3 is 15, 6 or 3 times 3 is 9. So all these would be similar. Okay. So that's kind of the just starting definitions that we'll look at, and there's going to be a couple other things we'll look at as we go here. But now let's do some examples. Number 25 says, which triangle is congruent to the given triangle? When you just look quickly, the first two look somewhat close, but C looks obviously not the same. Okay, because it's asking for congruent, so that means exactly the same. So you have to kind of look and turn. This one looks, even though they're pretty close, I think A is going to be the closest one. A lot of problems will even be more, you'll be able to tell even easier than this one, but this looks more like a kind of 90-degree angle that this one doesn't have. Okay, and again, they just kind of rotated that around, and it is the exact same shape. We'll just kind of go in order instead of doing the same type of problems. We'll just go in order here. So 26 really doesn't have much to do with this one, but it has to do with proportions and similar shapes. So we'll look at this one and talk about how to do it. It says, standing next to each other, a woman cast 74.4-inch shadow, and her 42-inch tall daughter cast a 50.4-inch shadow. What is the height of the woman to the nearest inch? So we have, sometimes a picture helps here. We have a woman, and her shadow goes this way, and her shadow is 74.4 inches. We have a girl, her shadow is 50.4, and they give additional information. Her height is 42. Okay, so these are going to be similar because in problems like this, the sun is up here, and it's going to be casting at the same angle if they're standing next to each other. Now, I didn't draw them right next to each other, but these would be proportional or similar triangles because of where the sun in relation to both of them is going to be the same. Okay, so now we have to set up a proportion. So I'm going to go woman to girl. Okay, and we want to find, the question is, what is the height of the woman? Okay, so my unknown pair, so this goes back to last session for some people that did that stuff, the proportions. I don't know the height of the woman, but I do know the height of the girl. Okay, now that's important that this column has to deal with the height from woman to girl. Now we can match up the shadow. So again, if you needed to, you could write, this is height, this is the shadow length. So the shadow of the woman we know is 74.4. That should be a 4. And the shadow of the girl is 50.4. Now to solve this, it should be pretty simple. We have, let's just cross multiply and divide. So if you didn't have me last session, or you don't remember, or you didn't get that far, take the diagonal that has two numbers and you multiply them. So 74.4 times 42. And then you divide by the third number. Okay, let's see, I'm gonna make sure. Yeah. Okay, let me grab my calculator here and take the, I'm sorry, calculator wasn't working. So 74.4 times 42 is going to equal 3,124.8. Divide by the other number. So divide by 50.4, and that equals 62. Okay. And again, that should make sense. The woman's shadow is bigger than the girl's shadow, so her height should be bigger than the height of the girl. So, which there's 3 of them that are, but 28 should be out. But again, there's how you set that up. Okay. So that one's a little more involved. Some of these are going to be quick. Some of them will be a little longer. Next page, 27 is a little bit of a quicker one, but you got to take your time here. It says which statement is false. Okay, so you got to go through all 4 of these statements and kind of make sure. So the first one, B is congruent to D. B and D. Now they look similar. Now that sure does look like they're not congruent though. So for now, I'm going to write false. And if you're very confident, you could be done right now. But let's look at these. And there's something I want to bring up here. It says, so one thing I should talk about here, just in case you don't know. This means congruent. And just the squiggly line means similar. Okay, so A is similar to F. So A and F. Now, I actually think they look congruent, but that brings up a good point. If 2 objects are congruent, they are also similar because they're proportional by multiplying by 1. Okay, so then A and F, I still think they look congruent. And then B similar to D. So B similar to D. They look like similar triangles, just different sides. Okay, so I would say if I had to pick one without measuring here, the one that's false is B congruent to D. Those do not look like the exact same size. Okay, number 28, the setup of this one is the important thing. So let's read through it. It says Alyssa wants to measure the height of a flagpole at her school. She places a mirror on the ground 50 feet from the flagpole, then walks backward until she is able to see the top of the flagpole in the mirror. Her eyes are 5.4 feet above the ground, and she is 9 feet from the mirror. What's the height of the flagpole? So this one, it's kind of confusing the way they talk about it, and they could explain it better. So you have the flagpole, you have the sun up over here somewhere. She's going to walk out 50 feet. Okay. Then she's going to start walking backwards. She puts the mirror right here. She's going to start walking backwards, and she's going to make it 9 feet. Okay. And then she can see the top of the flagpole in the mirror. So what this means is you got this vision going through here, coming down to the mirror. Okay. The height of her at this point is 5.4. Okay. So now what we actually have is all these angles are going to be the same. So you have two similar shapes here. So what I'm going to do here, just so you can see it better, is actually draw the two triangles. I know it's not exact here, but the one big triangle with the flagpole here, and that's 50 feet right there. And what we're looking for is the question is the height of the flagpole. So this is what we don't know. And then the little picture would be her. So I'm taking this little triangle out just so you can visually see it better. Bad triangle there, but that's 9 feet from there. And her height, her eyes at this point were 5.4 feet. So now what we have is similar triangles. So we're going to set up proportion. We're going to go big triangle to small triangle. Okay, and then we're going to go height to the bottom distance. Okay, so big triangle, that's what we don't know. But we know her height, or height of her eyes anyways, is 5.4 feet. Okay, then we're going to go the distance on the ground for the big triangle is 50. Okay, and then the distance on the ground for the small triangle is 9. Okay, so again now, cross multiply and divide. Take the diagonal with two numbers. So 5.4 times 50 divided by the third number. This equals 270. Divided by the third number is 30. Okay. So again, as you're doing this, I'm going too fast, pause it, copy things down. Okay. So the biggest thing there is kind of drawing that picture, understanding what's going on. And then setting it up here, big triangle, small triangle, and make sure you match up the right height and the bottom distance. Okay. That's probably that could be the hardest problem in this whole thing. Okay. 29 is not hard, but it's just a little goofy. So we're going to look at it here. It says one triangle is shown on the coordinate plane. Two vertices for the second triangle are shown on the graph. Which coordinates for the third vertex will form another triangle that's similar to the one that's shown? So let me break this down for you. So let's look at the triangle that they give us first and put some side lengths on here. So this is 1, 2, 3, 4. Here they go 1, 2, 3, 4, 5, 6. Now we can't exactly count there, so we're going to leave that for now. Okay. Now what they're saying is we have this. This is a side of our triangle, and it's 1, 2, 3. Okay, so now we're going to go through these other points. If we plot these points, what would we get for a triangle? So -6, -9. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9 would be here. So what we'd have for a triangle, we have 3 across there, and then here we have 1, 2, 3, 4. Okay, now I don't think this one's going to be similar because we have one side that's the same, the other side's half of that, and so if we went 3 to 6, that'd be times 2, and if we went 4 to 4, that's not times 2. So I'm saying that one's out. So let's go to the next one. It's -6, -2. So -6 is over here. -2 would be right here. So this would be 1, 2, 3. So our triangle would look like this. That's a bad picture, but we'd have 3 there and 3 there. So 3 there, 3 here. Again, if this side is half of this, well, this side's not half of that side. So they're not similar, they're not proportional. Okay, so let's go -6, -7. Okay, so -6 and 1, 2, 3, 4, 5, 6, 7. Be right here. So what we have for side here is we'd have 3 and then down 2. 3 and 2. So now if we look at it, 3 is half of 6 and 2 is half of 4. So those have a same relationship, or you can look at it the other way around. If I multiply this side times 2, I get a 4. If I multiply this side times 2, I get a 6. That's going to be our similar shape. Okay, this last one, just so you know, that would give you a 3 and a 1. Okay, so that would not be proportional. Okay, 7. I'm going to let you do that one on your own. It's going to be pretty similar to, like this one when I tore the 2 pictures apart. Go big triangle to small triangle. So here you got 60, we'll go with the 20, 84 we'll go with here. They're just looking at the heights of the ladder. Okay, so it says, just to help you with the question, it says how long is the shorter ladder? So they're looking at how long is that. Okay, so I'll let you guys do that one. Turn the page. Okay, so let's set this up here. One thing I want to go over here, it says given triangle ABC is similar to DEF. It says solve for X and Y. So now they set them up in the same position so they look similar. But the other thing to know is when they say they're similar, they have to be written in a certain order. Okay, so even the corresponding parts of the way they name a triangle will be the corresponding parts of the triangle. So what that means is if I looked at this side looks like it's the bigger version of this side. So AB would match up with DE. Okay, so DE would be shrunk. Now if we look at how this is written, AB and DE are the first 2 letters used. Okay, so now if we look, BC looks like it would match up with EF. Okay, well, even in the way it's written, BC is the second and third, EF is the second and third. And then AC looks like it matches up with DF. So I'm writing our corresponding parts here in proportion. Okay, well, even here, AC is the first and third, DF is the first and third. So you could tell what parts are corresponding even if there wasn't a picture. Okay, so now we want to find X and Y. So I'm going to fill in up here what goes in all these spots. So AB is Y, DE is 10, BC is 11, EF is 7, AC is 19, and DF is X. So if I want to find X and Y, I'm going to use this information here. So if I want to find X, okay, well, I'm going to use, I don't need to use all 3 of those. I will use this part right here. There's my proportion set up already. So find 2 corresponding sides have the same numbers. That's your known pair. And then you're looking for X and use its corresponding, which is 19. And I'll just make sure this is big triangle over little, big triangle over little. I'm going to cross multiply. Oh. So we're going to go 7 times 19 over 11. 7 times 19 is 133. Divided by 11. This will be 12.09090909. So it's 12.09 repeating. So it's either going to be A or D. So these are out if I think I did that right. Now the next one, I need to find Y. So I have this known pair, and this is my unknown pair. So I'm going to use these two. So I don't know Y. I need to find that. It corresponds with the 10. I have the 11 and the 7 corresponding. So now it's cross multiply and divide. So 11 times 10, all divided by 7. Multiply that. You divide, you get 15.71 something, something, something. Okay, so 12.09 for the first, 15.71 for Y. D is our answer. Okay. On that one, I might have went a little fast. If you need to rewind and watch it again, do that. This is a good problem to understand how the corresponding sides are proportional. You fill in what you know, and then you can solve. Okay. Number 32, I'll just give you a hint here. This one's going to be like 28. Okay, and I'll even label, just so you understand the picture, I'll label the parts, okay? And then you may want to separate the triangles. So he wants to find the height of the tallest building in the city. So that's, he wants to know what this is from here to here. So that's what we're looking for. He stands 310 feet away from the building. So from here all the way to here, or sorry, no, right here. Okay, he's standing that far away. It's 310. There's a tree 41 feet from him. So from here to here, it's 41. Which he knows is 21 feet tall. So the tree is 21 feet tall. How tall is the building? So if we separated these triangles, we'd have a small one. We have 41 feet there. We have 21 feet there. The big one, okay, 310 feet here. We don't know this. So now we kind of look at back at number 28 and look at how you solve that. Okay, I wanted to give you an example of how to set it up. Okay. 33. I'll show you at the end how to know which ones are like other ones, but this one is also like 28. Okay. So we won't do that one. So I don't think we have a lot left here. So let's go next page. All right. So 34 here. I have two triangles. It says find the measure of x. So another thing here, when people label similar triangles correctly, the order is important, and the corresponding letters in the name are the ones that are equal. Okay. Now, even looking at this, it might be hard to figure out, but so what I mean is T is the first letter. So angle T is going to be equal to the first letter in the second triangle, angle W. Angle U, because that's the middle one, it's going to be equal to the middle one of the other one, angle X. And then angle V is going to be equal to angle Y. So now we can fill in what we know here. Okay. And I'm going to show you something that I don't like about this problem in a second, but angle T is 60. So angle W has got to be 60, which is right here. Okay. Angle U is 58, which we don't know at the beginning, but 58's got to be equal to 58, and that's angle X, which is here. So that's 58. So now there's two ways you can go about doing this. okay? Either way, it's finding, if we find this angle, that's the same as this angle, and that's what we're looking for, a little x. Now, I think this is the bad part of this problem. They shouldn't use a little x to name the corner of y. They should have called this angle y, or measure of y. But anyways, the way you find this out in either triangle, because they're both the same angles, is you have to use the idea of remembering, okay, there's 180 degrees in a triangle. So if you take the two angles you know, add them up, the two that you know add up to 118. And if you take that away from 180, that'll leave you the remaining third angle. And that leaves you 62 with, so angle V equals angle Y, which is labeled small x. So that's the confusing part of this one, but if you follow along, that's how you find that missing angle. Okay. 35, I don't think we need to do. You will figure out that one. Finding ones that are similar but not congruent. 36, I'll just give you a hint. This is like 31. Okay, so I don't think we need to do that one. I will help you out on this one, on 37. So we got two triangles that are similar. Now, this won't be the way they actually look, okay? But it doesn't need to be drawn to scale. It looks like I'm just going to label these A, B, C. I'm going to go in the same order here, D, E, F. I drew the second one bigger because when I looked quickly, E, F looked like it might be bigger than the other one, 7. It doesn't really matter. You could draw them the same size and just label them. It doesn't matter. Now you're going to label things. It says BC is 7. It says EF is 16. It says FD is 2. Okay, and they want you to find AC. Okay, so now we have to make sure these are, they look like they'd be corresponding, but BC, second and third letter, that corresponds to EF. Okay, so those are corresponding. So we can set that up. We can go small to big here, or triangle ABC to DEF. So 7 goes with the 16. Okay, now we're looking for that spot, and that goes with the 2. It's corresponding with the 2. Now, obviously, this does, if that's 16, that does not look like it would be 2. It'd be way smaller, but it doesn't need to be drawn to scale. We didn't know the size at first, you just draw it that way. So now use cross multiply and divide. So take the diagonal of two numbers, 7 times 2 divided by the third. So you get 14 16ths. So there's two ways you can do this one. You could just go find the decimal. Take 14 divided by 16. It gives you 8.875. Well, if you look here, that's a decimal. These are fractions. So 0.875 is smaller than 1. So we know this is not smaller than 1. This is not smaller than 1. So what you need to do is, remember, anytime to find a decimal from a fraction, you just divide top divided by bottom. So you take 7 divided by 8. It gives you 0.875. So that's the right answer. If it didn't, then you'd go to the next one and divide and see until you get to 1. Okay? The other way you could have done that is, if you're good with fractions, you had 14 over 16, and you know the answers are in fractions, you look at this and reduce. 2 could go into both. So divide the top by 2 is 7, bottom by 2 is 8, and it's 7/8. Okay. Number 38, this is going to be like 26. So you're going to draw a picture. And you don't even have to actually solve it. You're just looking for the setup and the proportion. So, oh, sorry, I didn't write. This is like 26. So look at 26 to do that problem. Okay, turn the page. 39. It's going to be like 37. So you should try that one. Number 40. Okay, this is kind of like one we did on the other page, but I will do it for you quick, or at least set it up for you. Again, we have two triangles. I'm just going to draw them basically the same size, even though they're not going to be. And they say they're similar. We have A, B, C. So I went in that order. So X, Y, Z, I should go in that order. X, Y, Z. Then it says AB, BC, and AC are 10 inches, 13 inches, and 14 inches respectively. So that means in that order. So AB is 10. BC is 13. And AC is 14. Okay. It says XY is 11. Okay. And then it says what is XZ? So this one. So I'll do the setup for this one, and I think I'll let you solve it. So it's very similar to the other ones. But so now we're not going to use this 13 at all because that's corresponding to this. We don't need to know it, and we don't know it. Okay. The known, now just make sure you set this up right. So let's go ABC compared to XYZ. So take the known pair. 10 from that triangle is to 11 in the other triangle. Now just make sure you go in the same order here. This triangle, ABC, is 14, corresponds with the question mark over there. Okay. So now we're gonna, I'll let you finish that. You're just gonna cross multiply and divide. Okay. 41 is gonna be like our setup to 31. You don't have to do as much work as we did in 31. Okay. So take a look at that one. Again, if you don't end up doing it and don't understand it, you ask questions. And this one is like number 40. Okay. And then last thing I'm going to do is kind of show you on the key here. How, obviously, you can know a key can be used to figure out if you got the answers right or not. But the other thing it can be used for, I'll show you here. I'm going to circle the problems we did. So we did 25, 27, 29, 34, we did 31, we did 37, we did 40, we did 26 and 28. Now the reason I circled those is because they group these up by objective. So like if you were trying to do 32 and you couldn't figure out how they got D, you could say, well, that's from objective 7. Well, 28 and 26 are from objective 7. So I should look at those two and see which one is this problem kind of like. Okay. Then maybe it makes sense. You have another example to look at, you might get it. If it doesn't make sense at that point, then that's when you need to ask a question. Okay. So copy those notes down, send me pics when you're done. Try some of the other problems. And if you're not understanding them, that's when you have to ask questions. Okay. So again, let me know if you have questions.